Hello, good morning everyone. Today I'm going to make a video explaining to you the permute function in PyTorch. It is a really complex function I will describe because the logic behind is so simple, but once it comes to a high dimension, it is quite hard to be understood, So I've been trying to figure that out since yesterday. So this early morning, I finally figure out a proper way to present the reasoning behind it in a simple way. Okay, so let's start. Let's start with an example like this tensor here. I've written a tensor of 2 by 3 by 4 tensor here, so we'll call it x. So, and also simple words on the naming convention here. So we have the this as block 0, this is block 1, and so for each block we have 3 rows 0, 1, 2. For each row we have 4 columns. So here I will subscript the original position on the x. So for any particular value, for example this one, x112 subscripted, that means this value will sit in the original tensor of the block 1, row 1 and column 2. Okay, so that is exactly where this value sits, right? Block 1, row 1, 0, 1, this one, and column 0, 1, 2. So this value x112 exactly sit in the position described by the subscript. Okay, so we try to make things easier. So we work on an example today. It will be like permute 1, 2, 0. So this is a very typical permute in PyTorch. I think it is like the permute for an image tensor moving the color channel from the front to the back. Okay, from the front to the back. So here I will get you to see this final version of this permuted tensor. So this is for our validation purpose. So we will try to work out the final version for this function, and you will see how the new positions were found pretty easily. Okay, so the solution to understanding this is to have 3 stages. I'll introduce you here. So for the first stage, there will be identify the current position. For example, so for this x012, so remember what that means. 012. For the 012, that means the block 0, row 1, column 2. Okay, so let's see if that really fits. Block 0, row 1, column 2. Yeah, right. Row 1, column 2. Right. So we have successfully identified its current position. Row 1, block 0, row 1, column 2. So for the second stage, we'll come to update its new position. So for this permute, we move the first dimension to the back. So that means this 0 will be at the back. So we put a 0 here, and then this 1 and 2 will be shifted to the left by 1, right? So the 1 will become here, so the 2 will become here, right? So this is the result for the second stage. Okay, so we can move on this third stage safely. The third stage said reinforce the result of the stage 2 as the the current position. That means we just simply need to copy it from the result of stage 2, 1, 2, 0. And how to reinforce, how to so-called reinforce it. That means we follow the naming convention for the tensor structure. That means that 1 will correspond to the block, 2 corresponds to the row, 0 corresponds to the column. That means that the x012, which is our example, x012 will sit in this exact position of the new tensor, the permuted tensor. Okay, let's check if I'm right. Okay, so we'll see. So this will appear in the block 1. Okay, so this is the answer actually. So we will try to validate that. Block 1, block 0, 1, 2. So we will sit here, block 1. Oh, and row 2, okay. Row 0, 0, row 1, row 2 here. Okay, so, and column 0, that means here, column 0. Oh, great. We finally find that x012. That is what we are exactly searching for, right? x012. So this is the simplest way, I think, to figure out the new position of a permute function, permuted tensor, you know, if you don't have computer. So we can basically just handwrite all the answer one by one and follow these 3 stages of looking for the newly updated tensor. So let me recap again. So for the first stage, we identify the current position of a specific value, and then we update the new position according to our requirements in the permute. Third and last would be like reinforce the updated position as the current position, meaning we put the naming structure, the structure naming for each of the results in the stage 2, that you will find the newly updated position for a specific value. By doing this one by one, you will have no problem figuring out the new permuted version of your tensor. Thank you very much. I hope this will help you understand how the permute function work. Thank you. Maybe see you next time. And if you have any difficulty in understanding some specific function in PyTorch or something, you can let me know, and I will figure that out and upload as a video for everyone who also want to understand that, to know about. Okay, so thank you very much. I'll see you next time.